Hello! Smart Industrials works with industrial businesses to help you save energy. The program, offered through the Public Purpose Programs or PPP charge on your utility bills, provides your business with energy audits, technical assistance, web-based energy monitoring, and more. Contact our team to learn how to take advantage of these benefits. In this video, you'll learn about typical refrigeration equipment and identify ways to save energy through low-cost and no-cost strategies and small capital upgrades that can improve your system's efficiency and reliability. There are 5 general principles for reducing refrigeration energy use. They are maintaining system health, reducing load cycling or slowing evaporator fans, managing defrost, and reducing condensing pressure. First, let's talk about how you can save money. The refrigeration process is very energy intensive, and costs can be exacerbated by old equipment, poor or no controls, and lack of good maintenance information. Maintaining system health is pretty straightforward. Ensure all equipment is in good working order, including sufficient refrigerant charge, valves, liquid line filters, and motors. Cleaning evaporator and condenser fins and confirming uniform frost patterns on evaporators is a must. It also helps to ensure fans are spinning in the correct direction. Reducing the load involves things like keeping doors closed, shutting lights off when unoccupied, and installing more efficient lights that put off less heat. Additionally, it helps to maintain or upgrade insulation door seals, install auto door closures where necessary, and manage door heat. Manual doors or strip curtains can be upgraded to automatic high-speed doors that open and shut quickly to keep the cold where you want it. Cycling the evaporator fans is a control method that turns off the evaporator fans for most or all of the time that the liquid solenoid valve is closed. This is typically the largest energy-saving modification you can make to your system, as it saves fan power and reduces heat added to the space from fan motors. Some control systems have this option built in, so first check and see if your system already has this capability. If not, you have some options. First, you can install an aftermarket controller, for example, Key2Therm, Cool Expert, Cooltrol, Wick, XR75, or Einstein. Option 2 is to do custom wiring modification, which allows evaporator fans to cycle off when the liquid solenoid valve closes. Additionally, fans can be upgraded with electronically commutated or EC motors that offer higher operating efficiency and can also have the option of operating at lower speeds if practical. If cycling fans completely off is not an option for some reason, slowing them down can save a substantial amount of energy, as energy savings are exponential with a reduction in fan speed. For example, slowing down a fan by half drops the power consumption by 80%. Managing defrost can save energy if your system defrosts more than needed. That's because defrost heat, typically electric, uses energy to raise the temperature of the evaporator coil above freezing so that frost can melt off. This not only uses electric heat, it also adds that heat load to the room, which then again takes the refrigeration system energy to remove. Here's how you can save. Minimize defrost frequency and duration so frost uniformly covers 20 to 30% of the coils. At defrost initiation, reduce the number of defrost per day by 1. Then, monitor coils for frost. If coils are still clean after defrost, make another reduction. If coils are too frosted, Reset to prior defrost per day. Ensure defrost temperature termination thermostats are in good working order. Install aftermarket controllers with liquid runtime or defrost initiation features. And finally, minimize air infiltration into refrigerated spaces. Reducing condensing pressure is the last but not the least way to save. The goal here is to reduce the minimum condensing pressure setting to the lowest allowable limit. A rule of thumb is that compressor efficiency increases by 1.5% per 1 degree Fahrenheit reduction in saturated condensing temperature. The primary limitations to overcome include 1. Typically, thermal expansion valves, or TXVs, require 100 to 130 psi pressure differential. 2 is that some older compressors specify 70 degree Fahrenheit minimum condensing temperature, in which case you should target 5 degrees above this limit. An additional option is to install a condenser fan, variable frequency drive or VFD, and a floating head control upgrade. In review, this is how you can save refrigeration energy. Maintain system health by ensuring your equipment is in good working order. Reduce loads by keeping doors closed and turning the lights off. Cycle the evaporator fans by improving controls. Install more efficient fan motors and speed control. Manage defrost by reducing the amount of time the evaporators are in defrost and possibly adding defrost controls. And finally, reduce the condensing pressure to the lowest allowable level to save compressor energy. For more information about potential incentives or to schedule a free energy audit with the Smart Industrials team, contact us today or visit our website, sdsmartindustrials.com.